I will give a very brief status of HPC R&D in China. I will briefly to talk about the current status, and then I will talk about the Chinese next 5-year plan. For the current status, you all know that we have the 12th 5-year plan during year 2011 to 2016. We have the High Productive Computer and Application Service Environment project. It's a key project supported by the Ministry of Science and Technology in China. The main goal of this project is to develop world-class computer system. And the project could be said it's very successful. Supported for a Tinker-2 system. You all know that our Tinker-2 system keeps 6 times on top 1 until this Monday. And we are also glad to see that the newly born #1 system still comes from China, the Shenwei Taihu Light. It's a very impressive system. Maybe you have heard the talk yesterday afternoon given by the Professor Hao Huanfu. He stayed there. So if you have some questions about the details of the Shenwei Taihu Light, please ask him. So the performance of Taihu Light, the peak performance is 125 petaflops, and the within pack performance is 93 petaflops. And there are more than 40 sign nodes and more than 10 million cores. And another impressive point about this system is power efficiency. So it's more than 6 gigaflops per watt of core system power efficiency. And besides the system, we are also glad to see that there are some large-scale applications successfully running on this system. And we're also glad to know that there are 3 of these applications have been nominated for this year's Golden Ball Prize finalists. For the next 5-year plan in China, you know the policies and the mechanics of the organization of the Chinese key projects has been changed this year. So the new research plans not only supported by the Ministry of Science and Technology and supported by the many ministry of the Chinese government. So the divided by the 5 tracks in the new national research systems, including basic research program, mega research program, and key research and development program. And another is the enterprise-oriented research program, and the research centers and talents programs. For our HPC, we have the new key project on HPC. The strategy studies has been conducted jointly by the 863 key project and the Supercomputing Innovation Alliance under the guidelines of the MOST. A proposal of the TRIC-3 key project on HPC in the next 5-year plan has been submitted and approved in last year. And the key project on high-performance computing has been launched in February this year. And the key value of development exascale computer identified. First is addressing the grand challenges problems such as energy shortage, environment pollution, and climate change, etc. And another is enabling industry transformation to support the economic transformation. And the third part is the social development and the people's benefits. Another important part is scientific discovery. So the goal of the new key project also focused on the promote computer industry by the technology transfer, and also promote the self-controllable HPC technologies. You all know that we will take lessons learned from the recent embargo relations. And the goal and the major task of the new key project of HPC in China is wanting to strengthen the development of kernel technologies and pursuing the leading position in high-performance computer development, and promoting HPC applications, building up HPC infrastructures with service features, and exploring the path to the HPC service industry. And we totally have the three major tasks. First is to develop the next generation supercomputer. And also we need to support the CN grade upgrading and transformation. And another one, important one, is to develop domain HPC applications. And also the three tasks will be classified into basic research, key technology development, and application demonstration. So the first part is the development of the exascale computer. The basic research of this part, including novel high-performance interconnect for the next generation supercomputers. And another part is the new program model. And in the key technology part, we will develop prototype systems for verification of the exascale computer technologies. We plan to choose three units to develop the prototype systems. And we have given some prototype specification. The prototype system may include 512 nodes, and it will be 5 to 10 teraflops per node, and the power efficiency is supposed to be 10 to 20 gigaflops per watt. And the interconnection network, the bandwidth of the interconnection network should more than 200 gigabit per second. And also we have some MPI latency constraint. And this system software for the prototypes, and some typical applications to verify the effectiveness. So the first phase of the development of exascale computer, we will develop three prototype systems, and then we will choose one of them to go further to the exascale computer. So the key technologies, obviously, including all the challenges, including the multiple object optimized architecture, and also the power efficiency, and also the scheme for the high performance processor and the accelerator design. Also the whole system engineering infrastructure, and energy saving technologies, and also reliability and resilience, and also the system modeling and the performance measurement policies. So we expected to improve or develop the exascale systems at the end of this next 5 years plan. It's supposed to be year 2020, but it's still very hard work. So the specification of the next generation exascale computer should be, we established the link packet efficiency more than 60%, and maybe include 10 petabyte memory, and supported zettabyte storage. And the power efficiency is supposed to be 30 gigaflops per watt, and the interconnection bandwidth should more than 500 gigabit per second. And also including the related system software stack and support large-scale applications. And the second part is for HPC application development. So the basic research on exascale modeling methods, parallel algorithms, and parallel performance optimization, and developing an HPC software, application software, and establishes applications research and development centers to establish the HPC application ecosystem. So this is a basic research. And this is a key technology in the demo applications. We'll choose a numerical Newly reactor and numerical aircraft and numerical Earth and numerical engine. So we will try to develop high-performance numerical devices and their applications. Focus on this part. And another key technology in demo application, so the application software product development. So it's a fluid dynamic, structure, strength and material and biological. So we want to deploy the high-performance computers in a national HPC environment to achieving the numerical simulation as good as ones done by the commercial software. So we also want to transfer the system and the application. So for the research, development, and the dissemination mechanicals, we will run the HPC system and application platform. We want to establish 3 national level research and development centers for the HPC application software and to gather the talents from industry, university, and institute all over China to improve the level of the large-scale application. And the third part is for the HPC environment development. So the major task is to develop system-level software and operation platform for the national high-performance computing environment based on the thin grade. And the thin grade project, we also continue to support it by twice 5-year plan. We want to develop a national HPC environment with the leading class computing resource and the service capability, and also develop service systems based on the national HPC environment. So this is a basic research, including the models and the architecture for the computing service and the virtual data space. And the key technologies, including the new mechanism and enabling technologies requiring the service model operation and upgrading of the national HPC environment. So the thin grade, including the infrastructure, service model, and new operation mechanism. The whole thin grade will supposed to have the more than 500 petaflops computer resource and more than 500 petabyte storage and more than 500 application software and tools. And supported more than 5,000 users. This means the team users, and support the research, social and economic development of China. And the demo applications, including the integrated business platform and the domain problem-solving environment, and also application villages. We try to establish some domain-specific application villages to support the end users to use the whole supercomputer resource all around China. And another one is the platform for education to provide the computing resource and the services to undergraduates and graduate students to training the next generation of this HPC talents. For the progress of this key projects, the first core of the key project was issued on this year, February, and it covers selected topics from the 3 areas. And the proposals has been reviewed and will be approved soon. So at the end of the morning, we will talk about the collaboration. So I think this is the basic points we could talk about and discuss later. Thank you.